How do rivers continue to flow even when it hasn't rained for weeks? Where does the water come from? How does it get to the river? You know, I sometimes take for granted the fact that rivers are full of water. That's just how it is. But there's more to that story. Hi, I'm Mr. Peters, your guide to online grade 7 geography, and today our topic is the water journey, how water goes from rain to rivers. Water and rivers are one of the most important natural processes on the planet. Around it, life flourishes. Even for humans, if you look at the beginning of human civilization, you will find that our human story begins along the banks of rivers. They are so important. We're going to learn more about that process today, and stick around because later my dog Slightly and I are going to go on an adventure. We are going to follow the path of water from the source to the river. We all know that in a place like Canada, we are so lucky with the amount of water that we have around. Did you know that in Canada, 60% of the world's lakes are found here? 60%, that's amazing! We have not one, not two, but 3 oceans around us, and we are lucky enough to have rain, snow, or ice, or sleet, or precipitation in any form throughout the year. That's how it is, and it's something that we often take for granted, but is so amazing about being Canadian. Today, we are learning about 4 different ways that water gets to a river. Before we learn about those, I want you to take a moment and guess. What do you think? What are the ways that water gets to a river? You can pause the video for a second and think. Here are the 4 main river water sources. 1. Rainwater runoff. 2. Glacier or mountain snowcap melt. 3. Lakes. Or 4. Groundwater. Let's explore those. Rainwater runoff. Let's talk about rain. So imagine this scene. It's been pouring rain all day. Everything is wet. It's soaking outside. And then during the night, the rain stops. And by the time we get to the next afternoon, everything is dry. Where did all that water go? What happened to it? We're going to try to be logical. Okay, one place it went, some of it was used by the trees or the plants to help them grow. Some of it was absorbed down into the soil. Some of it soaked into those chair cushions that I forgot outside, and some may have evaporated into the air by the sun. And some of it will be runoff water, following gravity across hard surfaces like rock or pavement, following towards the lowest point, often ending up in small streams, also called tributaries, that flow into a river either close by or much further downstream. This is the point. Water flows down. Gravity is the biggest factor that controls the path of water. The area that drains down into a river is called a river's catchment area. So all the fields or cities along a river's edge that drain into it, that's the catchment area. Now, not all of the water in those streams, the runoff, will run into rivers. Some of it might run into a place with poor drainage. A place where the water is more still or stagnant, like a pond or a wetland, things like swamps, marshes, or bogs. It makes sense. But this is not the whole story. Rivers don't stop when it stops raining, even when it stops raining for weeks. Glacier and snow cap melting. Guess what? When it gets warm outside, snow and ice melt. Whoa, I know! You might be surprised at how much water comes from melting snow caps on mountains or glaciers up north during the summer, forming runoff streams or tributaries that come together to form the source of many rivers all around the world. We get these fast rushing, very cold streams. I could tell you this from experience. Please enjoy this photo of me fording a glacial runoff tributary in the Yukon. That water is so cold that just looking at this picture makes my legs hurt. Hashtag worth it. Lakes. Here is perhaps the most obvious answer. Lakes are a major source for rivers, as the water flows following gravity into the next lower lake or ocean. Rivers are also one of the biggest water sources for lakes. On this map, you can see the water flowing through the rivers into the Great Lakes, and then from lake to lake, from left to right via the rivers, and then finally taking the St. Lawrence River out towards the right at the Atlantic Ocean, heading east. Groundwater, the biggest source of water in a river. Let's figure out how groundwater works and what it is. Remember how we said that water flows down? Once water is on the ground, it is able to seep through porous land or rocks. Porous is a big word that means that the rock has tiny spaces, holes, or cracks in it that the water is able to pass through. Yes, water is able to pass right through some rocks. Slowly, but it does it. The water keeps going down until it comes to a point where there are either no more holes or cracks for it to flow through, or all the spaces are full of water already. It stops and becomes the water table. This water that's underneath the water table is moving around and is called groundwater. This is where you would drill a well to if you were drilling a well. Now, in what season do you think that water table is highest or closest to the surface? Typically, it's in the spring after the snow melt. That's when we have the most water seeping into our ground. Groundwater exists everywhere on Earth. In fact, there is an estimated to be 1,000 times the amount of fresh water underground than in all of the world's rivers and lakes. Isn't that incredible? 1,000 times more is underground. But there are points where the water table meets the ground surface. Here, the water leaves the water table, either as a spring or seeping directly into a wetland or a river. Let's see this in action. Hey, so we're going to try a simulation. I filled this jar of what I like to think of as a slice of the earth. We're going to imagine that the bottom is our bedrock. We've got some bedrock on the bottom that water cannot get through. Above that, we have some stones and pebbles that are tightly scrunched together. It would be more compact in the real world, but this is as compact as I could get it in my little jar. Above that, you can see that there's some dirt and some roots from our grass, and we have some leaves above it. I would like to try and show you that what happens when I add water to this little piece of average earth. The water is going to go down. We'll see how fast it permeates through our root system and into the stones, and then it's going to get to a point where it can't go down anymore. Once it reaches that point, the water is going to start to build up when it runs out of pores to move through. And that is where we have the water table. We're going to watch as the water table rises, and we're going to see what happens when the water table meets the surface. What happens then? Here we go. I'm going to add the water. And just a heads up, I have added blue food coloring. My water isn't this blue normally, just hopefully so we can see it a bit better. Let's add some water. Okay, did you see it trickle down there? It's filtering through the root system. Okay, we can start to see the line of where the water is at. We've got what we would call the water table, where the water has not been able to permeate through the bottom. We've now have groundwater. This is where you'd go to drill your well. And as you come up, you can see we have the water table. This is the level that the water's at. Now let's imagine we're in the spring. There's been a thaw. There's more rain, more water than usual in the land. Okay, as the water rises, it starts to get closer and closer to the surface. And like you'd expect, once we get to the surface, it's gonna stay, it's not gonna go anywhere else except for away. It's reached the surface, so now it can run freely following the gravity's path. So now we've actually gone above the earth. Now, let's imagine for a second that the earth wasn't completely flat. What? Yeah, I know. So the earth had a high spot over here and we had a low spot over here. When the water table reaches that low spot, it's going to exit the earth in the form of a spring or a wetland or a river, whatever else is around. I'm just going to keep adding water because it's fun. Now, it's one thing to see how this process works or be told about the sources of water. It's another thing to actually go there and figure out how the water gets from the source to the river. I'm about to go on an adventure. I hope you'll join me. Let's go! Welcome to the forest. We've just finished learning about how the water table and groundwater works. We're now going to try to see that in action. I brought you today to a forest in the Maitland Valley in the springtime. We're in April right now. And we learned about the concept that when the water table reaches the point of ground level, that's where the water exits the water table. And here we can see that. If you can see this water here, we've got the beginnings of a spring. It starts here, I'm at the top of a big hill, and it's exiting seemingly from nowhere. Most of this will be from the groundwater source. Some of it will be from the runoff from this hill above me, and it goes downhill, following gravity on its way to the river. I've just teleported downstream from the spring that we were just at up the hill that way. I wanted to see where the water went, and it comes and goes through the land until it comes out this other spring. Now, I happen to know that a prior landowner here had noticed that there was a spring forming on their property and had tried to capture the amazing potential of natural groundwater by actually channeling that water out of a pipe. And you can see it here. The cool thing about spring water is that spring water is one of the most natural sources of groundwater. Groundwater is heavily purified because it's gone through the filtration process of through all the cracks of the stones and the earth on its way down. So here we have some really natural water that's delicious for dogs and animals to drink. It's also delicious for humans. I often will drink spring water while I'm camping, but you need to make sure that you have some kind of filtration device. So bringing a water filter or something like that is super helpful for drinking spring water. Our challenge today, we are going to try and track the water from the source, leading down through the land, trickling through these streams, see if we can find out how water reaches the river. This is going to be a messy job. We're probably going to have to do some swamp stomping. We're going to see if there are any ponds on the way. But I think that we'll find it interesting and educational to track how the water makes its way from the source to the river. So here we are about 3 or 4 minutes downstream, and already our little spring, that trickle of water we saw coming out of that pipe, has joined up with other springs, and we can see that they've combined to create what is quite a bit of water now coming down to make us a real stream. When a stream joins up with a river, it's called a tributary. So here we are about 20 minutes downstream from the spring initially, and we had many other little tributaries join us on our way to this exit where we've exited into a pond. This pond has been fed by many different springs and tributaries leading in, and is full of silt, as I've just demonstrated. I'm now over my knees in the mud. It feels kind of gross, but you know, here I am in the water. That's okay. This silt is built up in many kind of soggy areas around this land that we're in, and it's very fertile. Actually, in wetlands, which is what we're about to enter into, the silt is specifically, and the soil underneath can actually absorb more water than average soil. And this is one of the really unique properties of wetlands, and I'm experiencing those unique properties in a big way at the moment. All right, I'm trying to pull my leg out. Wow. I'm hesitant to put my feet down anywhere. Okay, I've made it. You can see how far up, just this edge in the silt. I'm well over my knee. I'm up to here in the silt. Next, Slightly and I need to figure out where does the water go after it reaches this pond. We're gonna walk around and see if there's an exit point. There will be. The water is gonna leave the pond and head its way towards the river. So around the outskirts of our pond, Slightly and I found wetlands. There are a bunch of different types of wetlands. We have to figure out which type this is. You can see it's super mucky. That's a big characteristic of wetlands, where we have water that has exited its faster flowing stream and has entered a place that doesn't have very good drainage, and the water is often still or stagnant and soaks into the land, and it creates this different type of soil that's really rich and also very good at absorbing water. There are 4 types of wetlands. Swamps, which are characterized by having many woody plants and trees. Marshes, which mostly have reeds and that sort of thing. And we also have bogs, which are very mucky and have a lot of something called peat. And we have something called a fen, which is our 4th one. A fen is like a bog, but it has a bit less peat and more plant life. What do you think this is that I'm standing in? Is it a swamp, a marsh, a bog, or a fen? What would your guess be? So what is the value of a wetland? They are actually one of the most valuable but endangered ecosystems that we have on the planet. A wetland is nature's filter. It's the way for all that water that could have picked up anything on its way, pollution, any kind of materials, and when it enters this slow stage, because water slows down when it gets to a slow and stagnant area, it drops those minerals and pollutants that it was carrying, and it gets filtered, physically filtered through the reeds, but also because the water is slow, it filters out a lot of the pollutants. This is super important because as the water exits from a wetland, it enters streams and rivers, and this supplies a lot of the water that we use and play around with. One of the biggest risks to wetland habitat are the dominant culture. Many humans don't understand the value that wetlands give us as the great filter of our water. We don't like them because they're hard to develop, and they also are prone to having lots of bugs, so the dominant culture doesn't spend a lot of time in here hanging out like you might if you were trying to isolate yourself. The swamp is actually a great place to go if you're looking for a place to get away from other people. We can see this in our myths and legends with ogres and witches. We need to protect our wetlands if we want to be able to keep our healthy water that we love so much. So we've been stomping through the marsh for, I'm going to say 45 minutes now, on our way following the path of the water. How do we know which way the water goes? Water goes down. Water follows gravity. And if you look, we can see that it has come out of this marsh looking more like a stream. We have the flow of water again. It has found a way to drain out of the marsh. Couldn't hear that. As you can see, the water that we were just stomping through in that creek, following the swamp, it became swampy again. You can see all the reeds and the trees pushing up from the fertile ground, and then we get to another bigger pond. I'm not going to walk through this one. We're going to try to walk around and see where it goes after this. The water will go down, the water will get to the river. So we've made it to the other side of our pond, and I think we found where the water goes. If we look back towards the pond, you can really clearly see where the swamp was. We have the strong trees on the one side, but look at all the reeds, and you can see that the undergrowth is much shorter than the trees that are on either side. If we pan back around to look at this other side of the pond, we will see that it becomes swampy here as well, with our undergrowth also being lower to the ground, a lot of reeds, and we can see there's a bit of a stream that's run through here. The river! We made it to the river! We followed the water from the source. We hiked through the swamps for 2 hours, and now we've made it to where the water all comes, the river. We made it here, and I'm excited about what we're going to learn about rivers next.
Check out the dark spots all over these limestone cliffs. This is evidence of water coming from the escarpment above, through these cliffs and into the river. I was wondering about how some of this water was getting there, and it looks like it's going through a porous rock. Limestone for the win. It's been a cool day.
Welcome back. Oh, you will not believe the phone call I just had with the fashion agent who was telling me about how inspiring that new look is. I'm just ready to see hip waders and tweed blazers walking down the streets of Paris. Get ready, it's coming soon. We learned that river water comes from 4 sources: rainwater runoff, glaciers and mountain snowcap melting, lakes, and groundwater. We learned that groundwater is water that has soaked down into the earth and the rocks until it can't go down any farther, and that the top level of the groundwater is called the water table. And that when the water table gets high enough to meet the surface, the water comes out in 3 different ways. The water can come out as a spring, which forms streams or tributaries like we saw. It can seep directly into a river, or it can seep directly into a wetland. We learned that wetlands are nature's filter that gets rid of toxins and pollutants in the water, and that wetlands are one of the most endangered ecosystems on the planet, and that humans are responsible. We learned, most of all, that water goes down. Water goes down. Okay, something that I also learned while exploring is how awesome the job of a geographer or a geologist must be. We had a great day in the wild. We brought a picnic, enjoyed life by the river. I challenge you to have a great day as well and follow a water source. See where it takes you. Now it's your turn. Check out the activities and resources in the lesson that was paired with this video to learn more about the journey of water. Until next time, I'm Mr. Peters. Bye!